Welcome to Homework Lib.
In this case, we're dealing with the Henderson-Hasselbalch equation, which tells us that the pH is equal to the pKa plus the logarithm of the concentration of A minus, which is the conjugate base, divided by the concentration of the weak acid that we have. This expression, since the total volumes are going to be equivalent, will be the same as putting directly the amount of mole that we have of each of the species. Because the concentration, since both of them depend on the total volume, we can directly divide them and they are going to cancel out. Okay? So now, what we are going to see is what is going to happen, or what are the requirements that we have for each of the different pHs. For example, we know that the pKa for acetic acid is 4.7, and we're told to find the ratio in between the number of acetic acid molecules and the number of acetate molecules that we're going to have in solution. In the first case, where the pH is equal to 2.7, what we are going to do is solve for this ratio directly. 2.7 minus 4.7 gives us a value of minus 2. And this is going to be equal to logarithm of Na minus divided by NHA. Getting rid of the logarithm, 10 to the minus 2 will be equal to N of A minus divided by NHA. So this means that we have a 1 to 100 ratio for these guys to be equal, correct? So we can put that directly in our table. We have pH, we have number of acetic acid molecules, so HA molecules, and number of acetate molecules, A minus molecules. I'm going to write down molec instead of mole just to differentiate. So for a pH equal to 2.7, we find that we have a 1 of A minus to 100 of HA molecules. Now, what would happen if the target pH was 3.7 instead of 2.7? Well, the only thing that is going to change are these three numbers over here. So this would be 3.7. 3.7 minus 4.7 is minus 1. 10 to the minus 1, which is 1 to 10. And we find directly that ratio. So we have 1 of A minus to 10 for a pH equal to 3.7. For 4.7, we know that this is equal to the pKa, so we require a 1-to-1 ratio directly. And now let's see what happens in the other two cases. For 5.7 and 6.7, for 5.7, again, the only things that are going to change in our procedure are these numbers over here. In the case for 5.7, 5.7 minus 4.7 gives us 1. 10 to the 1 is equal to 10, right? So we have a 10 to 1 ratio. But now acetate is more abundant than the HA. And for the final case, we're going to find that this corresponds to a 1 to 100 ratio, because here we're going to have 6.2, 6.7, 6.7 minus 4.7 is equal to 2. 10 to the 2 is equal to 100 over 1. And that would be all. Thank you very much.